All right, today we're going to be doing the Honors Algebra 2 Chapter 6 review questions, getting ready for the Chapter 6 test. Many times throughout this one, I'm going to be mentioning you need to pull out your calculators and things like that. So I will kind of walk you through the keystrokes a little bit, but ultimately you're going to have to understand how to do the graphing calculator or the calculator itself. So the very first question here, they're asking me to graph, tell whether or not it's exponential growth or decay, and then graph the function. So this is growth because this value is greater than 1. This would be considered growth. And now you just want to do a simple XY chart, plugging numbers in for X. And again, your graphing calculator could come into play here. So if I put -2 in for X, I'm going to get -9 30-seconds, 3/8, 1/2, 2/3, and 8/9. Again, if you write those as decimals, that's fine too. And then you end up having to graph this. So -2, 9 30-seconds. Again, that number is fairly small. So 1/2. Notice this is growth, but it is going at a very small rate of growth. And so you'll go along the x-axis and it will steadily go up. Obviously, the further you go, the more upward trend you will find. But because that value is slightly above 1, it is growth. Next one will be considered decay. This one's a lot easier for your XY chart. And again, a graphing calculator could help in this. So I'm going to do the same points again. And then I'm going to graph those points. So -2, 9, -1, 3, 0, 1. And then again, you're going to start getting smaller and smaller and smaller because it is decay. It will not cross the x-axis. And so graphing an exponential curve. Next one, again, because this value is a positive values of x, you're going to talk about growth here. This one, you basically have to do a graphing calculator because you're going to find values of e. This is rounding it to 2 decimal places. This is 0.02, 0.13, 1, 7.39, and 54.6. So again, graphing those then, 2 would go way off the graph, 1, 7, 0, 1. And again, these numbers get ultra small. But that would be considered growth. And then the last one again is decay because you have a negative value of x, e raised to a negative value of x. So -2, again, rounding to 2 decimal places. Using a calculator and then graph those points. So -2, -1. And again, these numbers keep getting smaller and smaller. Decay. Next, word problem. This is the population of a city has increased at a steady rate of 2.12%. As a decimal, that is 0.0212. If the population in 2012 was 150,000, using the formula now, y equals 150,000, parenthesis, 1 plus the rate that we just discussed, raised to the t power. That's the model. Now they're asking for a specific year, and we're going to put 8. The reason you're going to put 8 is because the value, it starts at 2012. So now 1.0212 raised to the 8. Using a calculator then, I would get 177,409. Label people. Notice that I did round to the nearest person, ultimately because if we were estimating a population, we wouldn't have tenths of a person. Rewrite the equation in exponential form. This is the spiral technique. 3 to the 4th equals 81. So going the opposite direction, now I have a base of 1/2, exponent of -5, value of 32. So putting something in logarithmic form. Another graph. Again, if you spiraled this out, 2 to the y equals x, and instead of doing an xy chart in which you're plugging numbers in for x, you're now going to plug numbers in for y. So if I put -2 in for y, I would get 1/4. 0, 1, 2, 4. And so plotting those points, 4, 2, 2, 1, 1, 0. And again, these keep getting smaller. So now you have a logarithmic curve instead of an exponential curve. Transformations, describing what's happening. Notice going from x to negative 3x, which means you're replacing x with, so we got a horizontal shrink by a third and a reflection on y-axis. The minus 5 means that's a translation down 5. Another describe the transformation now again. Notice the 1/3 out in front. Order does make a difference. So if I did that first, it's a vertical shrink by a third. And then the next thing, I replaced x. So we're talking about a translation to the right 4. And then another translation up 5. So translation to the right 4, translation up 5. Now they want me to write the rule. I want a horizontal stretch by a factor of 3, which means I'm going to replace x with 1/3 x, followed by a translation up 3, which means I'm going to add 3 to the function. Evaluate common logarithms. Now, the use of common logarithms means you're going to write out. Those of you with calculators that can do this still need to show you understand how to evaluate using common logarithms. The log of 20 divided by the log of 5. Now, using a calculator, rounding to 4 decimal places would be 1.8614. Evaluating. Now, if I can get the bases to be the same, that is the first thing that I should do. So I can change 81 to 3 to the 4th. So 1 over 81 is 3 to the negative 4th. This will make this question a lot easier if you can get the bases to be the same. Multiplying power to a power. Once the bases are above 1 and equal to each other, I can then set the exponents equal. Solving now using some algebra skills. I'm going to add 4x and get 6x. I'm going to add and get 3. Divide by 6. I get x to equal 1/2. Now, what happens if I cannot get the bases to be the same? Now I have to take the log of both sides of the problem. By rule, exponents of logarithms can be moved out in front of the logarithm. Now, depending on how you want to handle this, you can distribute, subtract, and then divide, or you can divide right away. Again, your algebra skills here. I'm going to divide right away. So I'm going to end up with x plus 3 equals log of 11 divided by log of 2. Then I'm going to subtract 3. Plugging that into my calculator now. I'm going to take log of 11, hit enter, divided by log of 2, hit enter, and subtract 3 and get 0.4594. Taking the log of both sides. Now, this was going to require a little bit more work because I end up having an x on both sides of the problem. So I move it out in front. So remember, by rule, if I have a log raised to an exponent, I can move the exponent in front times the logarithm. This time I have to distribute. So notice that I multiplied log of 2 into both of those. Now, I want the x's. You'll notice there's an x on one side and an x on the other side. I want to get the x's on the same side. So 4 log 2 equals x log 5 minus 3x log 2. So I subtracted 3x log 2 to both sides. Now, greatest common factor. So x log 5 minus 3 log 2. I'm going to take an x out of both of those. And now comes for the big finish. I'm going to divide both sides by that entire parenthesis. Log of 5 minus 3 log 2. So now, x equals, time to pull out the calculator again. I'm going to take 4 log 2. I'm going to hit enter. I'm going to divide that by, in parentheses, log of 5 minus log of 5 minus 3 log 2. When I type all that in, I get negative 5.8991. Isolate. So I can subtract 5 from both sides. I can divide both sides by 3. Now, instead of taking the log of both sides, I'm actually going to take the natural log of both sides. This still goes out in front. So the rules that we still use when using logarithms, we'll still use doing natural logarithms. The natural log of e is just 1. So now, negative x plus 2 equals natural log of 5. Subtract 2. So negative x equals natural log of 5 minus 2. Be careful with that. When you're typing that into your calculator, you need to make sure you understand you're taking the natural log of 5, enter, or close the parentheses, minus 2, and then dividing that by negative 1, you get 0.3906. Spiral, 4 to the third equals 2x plus 8. 4 to the third is 64. And now it becomes a basic algebra question that you should be capable of solving. So 56 equals 2x, divide by 2, x equals 8. Uh, 28. Sorry, I was distracted there for just a quick second. X is equal to 28. Next one. Again, spiral. It's based e. Calculator, e to the third. You're going to, doing a little calculator, e to the third plus 4, and then divide that by 3. So using a calculator, I get 8.0285. Sorry about that O there. Combining logarithms. This is where things start getting a little bit tricky for some people. Okay, anytime I have a log plus a log, I can multiply the values. Then it all depends on what kind of problem I have. I have a log equaling a log. I can take the anti-log of both sides. And so now setting this equal to 0 when solving like you would a quadratic from chapter 3, negative 9 and positive 6, x would equal 9 and x would equal negative 6. Now the only problem is you have to make sure these values stay positive. And so if I plug negative 6 in there, it will not work, and only positive 9 will work because I need those values to stay positive when doing logarithmic functions. Exponent, the 3 becomes an exponent. Combining these two logarithms together using multiplication. So I'm going to take 8 times x plus 7. Spiral, 4 to the 4th equals 8x plus 56. 256 equals 8x plus 56. 8x equals 200. Divide by 8, x would equal 25. Again, if I can get the bases to be the same, this is an inequality. 625 is, breaking this down a little bit further. Sorry about that. This would be 5 to the second. 625 is actually 5 to the 4th. So now, 5 to the 2x plus 4 would equal, or be greater than or equal to 5 to the negative 4th. Sorry about that. 1 over 625. 625 is 5 to the 4th. So 1 over that would be 5 to the negative 4th. Now that the bases are the same, the exponents then can be set equal, or in this case, greater than. And now it becomes an Algebra 1 question that I hopefully am capable of solving. Now I can't get the bases to be the same. So now I'm back to taking the log of both sides, moving the exponent out in front. I don't have to distribute because I only have one x in the problem. I can divide. And then subtract. And now I got to pull out my graphing calculator, or a calculator that matter. Log of 7 divided by log of 3 minus 4 would be negative 2.2288. Divide by 3 first. Always isolate the inequality. Take the natural log of both sides. Natural log of 8. The natural log of e is just 1. So then when I subtract 1, I'm going to take natural log of 8 on my calculator, divide that by, natural log of 8 minus 1, and I'll get 1.0794. Again, a lot of calculator work goes into this particular chapter. Spiral, please make sure that you keep this x minus 5 greater than when you do the spiral. Now, you always have to worry about the fact that if your domain is okay, x is greater than 21, would that cause a negative in the x minus 5? The answer to that is no, it wouldn't cause a negative, so I am done. I don't have to worry about the domain. Obviously, we will have to worry about the domain at some point here. I have a log less than a log, so x plus 1, 3x minus 11. I'm going to subtract 1x. I'm going to add 11 and divide, so I get x to be greater than 6. Again, that does not cause an issue in either one of those, so that's all I have to do. Spiral, 2x minus 1 is less than 5 to the second, and solve. X would be less than 13. That does cause an issue. So we finally have a time in which we have to worry about the domain. 2x minus 1 must be greater than 0. So as I am solving this, x also has to be greater than a half in order to keep the domain and the solution. So again, anytime you see a less than, or anytime you see a situation in which this part of the logarithmic function is going to be negative, you have to worry about the domain as well. Writing an exponential function, you are given an x and a y, so y and an x, and then you're given a y and an x. Solve both of them for a. A is equal to 8 over b cubed. A is equal to 2 over b to the 5th, which means these two must now be equal. Cross multiply. So 8b to the 5th equals 2b to the 3rd. Always divide by the smaller b value. So 8b squared. 8b squared equals 2. B squared equals 1/4. B would equal 1/2. Now, going back up here into either one of these two problems, I now am going to put b equaling 1/2 in. So let's say I use this one, I don't have a lot of space. A is equal to 1/2 cubed, which is 1/8. So multiply, I get a to be 64. So writing the equation, y would equal a b to the x. So there'll be one of those on your test. And last but not least, this is entirely a calculator question. You're going to go to stats. You're going to enter it into stats, edit, put the numbers in for the x or L1, put numbers in for L2. You're going to ask the calculator to do a exponential to find a and b. So you should get roughly 0.8999 raised to the x. Then it's going to ask you to plug 10 in, and you will get roughly, if you get 10 years, you should get 1464.40. The only other thing that is not on the review guide that you have to be aware of is the fact that don't forget the word problems from the worksheet 6.6 day 3. This worksheet has a bunch of word problems on the back side, and those problems are on the test tomorrow. Please study tonight, and good luck.